Do you ever find yourself stuck on a difficult problem like this? Well, in this video, we're going over prime factors. Let's do it. Alright, so first, how many distinct prime factors does the number 424 have? Alright, so first we need to know what a prime factor is. So a prime factor is a number that cannot be divided by any number other than 1 in itself. So for example, 31 can only be divided by 1 and 31. Alright, but that's just a prime number. A prime factor is any number that is divisible by 31. So in this case, the 31 is a prime factor. But it could be any other prime number. So for example, 5 can only be divided by 1 and 5. And 20 divided by 5 equals 4. Which means 5 is a prime factor of 20. Alright, now that you know what a prime factor is, let's solve this problem. Okay, so how many distinct prime factors does the number 424 have? So we have our number 424. Alright, so 424 can be divided into 2 and 212. Next, 212 can be divided into 2 and 106. Next, 106 can be divided by 2 and 53. Alright, so now let's look at these numbers. So 2 is a prime number because it can be divided by any other number than 1 and 2. And 53 is also a prime number because it cannot be divided by any other number other than 1 and 53. So these are our two prime factors. However, we need to write this in a prime factorization. So we have their 2's first, so 2, and you have to figure out the power. So there's 1, 2, 3 2's, which means it's 2 power 3, multiplied by 53 to the power of, there's one of them, so it's just the power of 1, but we don't have to write that. So this is our prime factorization, 2 power 3 times 53. Alright, now the distinct prime factor is each number. So there's a 2 and there's a 53, meaning there's only 2 distinct prime factors. And that's your answer. Next, the prime factorization of 1240 has exactly how many distinct prime factors? Okay, so we have to do the same thing as the last problem. So 1240 can be divided by 2 because it's even. So 2 and 620. Next, 620 can be divided by 2 and 310. Next, 310 can be divided by 2 and 155. Alright, next. So 155 can no longer be divided by 2, so now we have to divide it by another number. So we have 155, so we can divide this by 5 because it ends in 5. So 155 divided by 5 equals 31. Alright, 31 is also a prime number, so we can't divide any further. So now we have 2 power 3 because there's 3 2's. 5 power 1 because there's only one 5, and 31. So our prime factorization is 2 power 3 times 5 times 31. So there is 3 distinct prime factors, and that's your answer. Next, what is the sum of all the distinct prime factors of 234? Alright, so we can start off like our last problem. 234 is an even number, so it's divisible by 2. So 2 and 117. Next, 117 is divisible by 3, so 117, 3 times 39 is equal to 117. So we have 39 over here, and 39 is divisible by 3 and 13, which are both common prime factors. Alright, so now we're done with our prime factorization. We just need to write it out. So we have 2 power 1, because there's only 1 2, so we don't even need to write the 1. We have 3 squared because there's 2 3's, and we have 13 because there's only one 13. Alright, so that's your prime factorization. Alright, now the question is, what is the sum of all distinct prime factors? Okay, so our distinct prime factors are 2, 3, and 13, so we just add them up. So 2 plus 3 plus 13 equals 18, and that's your answer. Next, 1728 has a prime factorization of 2 power x times 3 power y. What is the product of x and y? Alright, so all we have to do is find the prime factorization of 1728 and then find the exponents and multiply them. Alright, so that's pretty simple. So 1728 divided by 2 equals 864. Next, 864 divided by 2 equals 432. Next, 432 divided by 2 equals 216. Next, 216 divided by 2 equals 108. Next, 108 divided by 2 equals 54. Next, 54 divided by 2 equals 27. Alright, and now we just have 27, which is no longer divisible by 2, so we have to divide it by another number. So in this case, we can divide it by 3, which gives us 9. And then 9 can be divisible in 3 and 3. Alright, so now we have all the numbers. Let's find the prime factorization. So we have 1, 2, 3, 4, 5, 6 2's. So we have 2 power 6 times 3 power 1, 2, 3, because there's 3 3's. So 2 power 6 times 3 power 3. Alright, so that means 6 is equal to x and 3 is equal to y. Now that we know that, we just have to multiply 6 and 3. So 6 times 3 equals 18, and that's your answer. Alright, that's it. Thanks for watching. If you found this video helpful, please make sure to show your support. These videos take a lot of effort to make, and I would really appreciate it.